Hi. In chapter 13.2, we're going to a little more formally talk about slope. Slope, which we abbreviate with the letter M from some German word that I forget what it is defined as the change in y divided by the change in x, or the rate of change of y. The rate of change is when we divide by whatever the x value is, which tends to be time very often in a graph. All right. Now, others might think of this change in y as the rise, and the change in x as the run. So let's say that we have this line here. When we're calculating slope of a line, we have to make sure we find good integer points. So this is a nice integer point. And then the next one we hit isn't, well, this one's close, but isn't all the way to here. All right, so there's our two integer points that are given to us. Now, we need to find out the change in y, how far down we go. We could go up from this or down from this. I'm going to go down from this. So we have to find our change in y. And this length here is delta y, also known as the rise. Okay. And then this length here is delta x, change in x, also known as the run. All right, so a lot of people call this rise over run. Right, you've probably seen that already. So let's see, the delta y. Well, this looks like it's a difference of 4, but we're going down. If we're going from this point to this point, we're going down. That's down 4, so -4, we call that -4, all right, for our delta y. And then our run, we're going across. Let's see, 1, 2, 3, 4, 5, 6, 7. 7. Make sure you count the spaces, not the lines. Notice I started here and I went 1, 2, 3, 4, 5, 6, 7. I didn't start here and say 1. I went 1, 2, 3. Okay, so we got 7. So -4 over 7. That can't be reduced. We're all done. And in fact, this line is a negative line. It's going down, right? It would be okay to think of this as starting over here and going up 4 and then back 7. That means the negative will be on the 7 instead of the 4, but you know in a fraction that doesn't matter. One negative means it's negative. Our line is in fact going down from left to right. Okay. So second example, and then you'll be all set to do the homework. We're just given points. So we're not given a graph. We're not given this visually. We're just given points. So again, we need to have change in y divided by change in x. Now change means the difference. So we're going to subtract one y value from the other. Let's say we start here with one y value, -1, and then we're going to subtract 1. All right, so we're take one y value and subtract the other y value. And then for the x values, we have to start with the same or the corresponding x value that went with where we started. This is -1 and this is -1. So the change is the difference. So this is -1 minus this 1. That means we have to take the -3 and put it down here. Sorry, that's -3. And then we have to subtract this 5 from that. Okay, so -1 minus 1 is equal to -2. And -3 minus 5 is equal to -8. Now that's one negative over another negative. That means that's positive. So this is a slope of 1/4. That means it goes up 1 for every time it goes across 4. So it's going to have a slope something like this. It's going to have a slope of, let's see, up 1 and across 4. 1, 2, 3, 4. So it's going to have some type of slope like this, right? A gradual upward slope. Okay. Now, the formula that people use for this is m equals y2 minus y1 over x2 minus x1, where x1, y1 is one ordered pair, and x2, y2 is another ordered pair. We always put the 2 minus the 1 and the 2 minus the 1. It doesn't really matter, to be totally honest. It's just that's the general consensus of how textbooks make this formula. But it is taking one y value and subtracting the other, and taking the corresponding x value and subtracting the other x value. And that's how you calculate slope given 2 points.